All right, perfect. I'm recording again. Here we go. Okay, who's reporting from breakout room number 1? That was Grant and Alyssa and Lauren. Who's reporting from that one?
That was me.
Okay, wait 1 second. And who's reporting from my second breakout room? From Josh and Grace and Andrew Grace's. Okay, Lauren, 1. Give us 1.
Proof by cases.
Proof by cases, cool. Grant, your internet is being spotty. Okay, we will see what happens, and if it doesn't work, it doesn't work, and that's why we're recording class. Grace, what do you got? Give me 1.
Truth tables.
Truth tables, okay, and that would be propositional logic, absolutely. Lauren, you're up.
Just going off of that one, like the rules that we wrote down.
Yes, so we can do propositional logic. We can either prove it by a truth table, or we can do it with all those rules that we wrote down. Cool. Grace.
Direct proof.
Direct proof. Cool. Lauren.
Contrapositive.
Proof by contrapositive. Cool. Grace.
And contradiction.
Proof by contradiction. Yes. Lauren, anything else that you have on your list that we did not mention?
We didn't know.
I don't have anything either. Okay, so those are the ones that we have up to this point. Today, we are doing a new one called biconditional proofs. So let me get my whiteboard going here. The reading assignment was good, so that definitely helped at this point. Now, here's the thing. When I have my whiteboard going, I can't see all of you at the same time. So what you're gonna need to do is, if you have a question, you're gonna have to virtually raise your hand because I can't see you all in the picture. So could you please try virtually raising your hand for me? Figure out how to do that, please and thank you, so that I can see where things are going. Okay, 4 of you have, that's good. 5 of you have, and Grace is going to in just a minute.
Did you say to raise your hand?
Yeah, raise your hand.
Oh, okay.
Because I can't see all of you in the picture when I have my whiteboard going. Cool. Okay. All right. I am going to lower everybody's hand, or you can do it yourself. Awesome. All right. So we are doing biconditional proofs today. So here's the plan for class. We're going to talk about the basics of biconditional proofs. And then we are going to do a couple examples, all right? So this is section, I'm going to apologize for my handwriting, 7.1. I have things to move here. Sorry, my screen, you can't see this, but I need to get stuff situated with my whiteboard so I can write. Okay, section 7.1, biconditional proofs. Biconditional proofs. It's hard to underline on a whiteboard. You can't, oh, that's terrible. Okay, all right, so a biconditional proof, remember, we are trying to prove this statement with arrows in both directions, right? P, if, and only if Q. So that's what we're trying to prove in this particular statement. Remember what that was logically equivalent to. And by the way, you guys can decide what the best way to take notes is at this point in time. If you want to take notes live off the computer screen, or if you want to go back and do some reading, remember that my notes are also going to be posted for you. So you can do it that way, however you want to do it. Okay, so remember what this is. This is 2 implications. So it's P implies Q and Q implies P, both. Remember, that's logically equivalent. We've got those 3 logical equivalents. So we have to do P implies Q and Q implies P. So if we want this left-hand side here to be true, then when we have 2 ands on the right-hand side, we need both of the ands on the right-hand side to be true as well, right? The only way that an and statement can be true is if both of the pieces of the and statement are going to be true. Everybody good? I can't see you, but I'm going to assume that everybody's good. So what we have to do to prove a biconditional, so to prove P biconditional Q, we need to show 2 things. And this is what I asked you in your reading assignment, and everybody got it really well. We need to show P implies Q, and I have to do both of these. Q implies P. So basically, a biconditional proof is 2 halves. Oh, I can see you all. Awesome. Okay, there's a small enough class that I can. So biconditional proof is 2 halves. It's a proof with 2 halves. You got to do 2 directions of the proof. So the first direction here is called the forward implication. Sorry, now I need to move you. forward implication. And the backwards is called the reverse implication. And remember that the reverse implication usually starts with the word conversely. That's how you know that you have a reverse implication. So usually we start with the word conversely. Okay, one more thing. My whiteboard organization is not going to be the best, so we're going to have to deal with that, but that's okay. So P double arrow Q. Remember the way that we say this? The book says it as P if and only if Q, right? Bad at me, tell me you remember that from the book, P if and only if Q, right? The book does not do this next part, and I really don't know why, because every single other mathematics textbook will do this next part. Mathematicians don't like writing out stuff if they don't have to, and if and only if is a lot of stuff to write out. So what we usually do is P, I, F, F, Q. So in other words, IFF is totally shorthand for if and only if. That's my shorthand. You are more than welcome to use IFF. That is very, very standard in mathematical notation. Very standard. I wish this book would do it, and it doesn't. It's more standard than NTS. Remember, NTS is need to show, right? That sometimes gets used and sometimes isn't. IFF, you read it as if and only if. You don't say IFF, but if and only if. IFF is super, super common to use. Okay? All right, so we're gonna do a couple examples. I'm gonna do one together with everybody, and then I'm gonna divide you into breakout rooms, and you're gonna talk through another one. So, any questions on the basic idea of a biconditional proof before we go ahead and do an example? Anybody, anything? It's stuff we've done before. So you have to look at all your proof techniques that we made a list for, right? Direct proof, proof by contrapositive, proof by cases, proof by contradiction. Hopefully we won't have to use that one. And you're just doing two halves. You're doing something twice. You're just doing two previous proofs that we've done twice. That's why this is a really good section to start with and jump back into, because it's stuff we've done before. All right, everybody good? Okay, all right, let's try one. So our very first proof on a virtual whiteboard. Here we go. All right, here is my statement that I would like to prove. So we'll do claim. We're going to need to remember some definitions. If x, which is an integer, so x living in the integer is odd, and I don't want to start with if because I am doing if and only if, so hang on 1 second, we're going to say, sorry. Okay, so, ooh, no. I'm sorry, my whiteboard went away. Give me just a second. I'm new at this. I'll get better at this. Promise, really. All right, so there we go. X living in the integers is odd. If and only if 3x plus 6 is odd. Okay. X living in the integers is odd if and only if 3x plus 6 is odd. So let's do a little prep work first. Normally we wouldn't do this, but this is our first one. So we are going to do a little bit of prep work here. I'm not sure what's going on with my whiteboard. Give me just a sec. So what's my P statement in this case? You don't have to virtually raise your hand. I can see you now. P statement. What's my P statement in this case? Somebody be brave, volunteer. You were talking to each other before. You can talk to each other now. What's my P statement in this case? What's the first half? Really, I can see you. So somebody be brave and volunteer. P statement. What do you got?
X lives in the integers is odd.
Yeah, so I put X lives in the integers. So X lives in the integers is odd. Absolutely. That's my P statement. What's my Q statement? Somebody else. What's my Q statement in this case? My Q statement. This isn't supposed to be the hard part. Josh?
3x plus 6 is odd.
Absolutely. 3x plus 6 is odd. Okay, so here's my proof for my biconditional. The way that we usually divide it out is I will write a forward that's supposed to be an arrow. There's a little extra thing there, and I'm not sure how to erase it. So I will mark the forward implication with the forward arrow. That's the first part, and then I'll mark the reverse implication with the backwards arrow. So in this case, we get to assume that X is odd. And I need to show that 3x plus 6 is odd. We clear on that? Making sense? If I assume X is odd, then I need to show that 3x plus 6 is odd. Everybody good? Everybody good? Okay, cool. All right, so then what's my next step? Because X is odd, we know what? Go back to your definitions. What do we know? Because X is odd, we know what? This is stuff we've done a while. It's been a couple weeks, but this is what we know. What do we got? If X is odd, we know.
X is equal to 2a plus 1.
Absolutely, keep talking.
For a living in the integers.
Yep, for some A living in the integers, or you could say where A lives in the integers. All right, so need to show that 3x plus 6 looks like what? You need to show that 3x plus 6 looks like what? What's my need to show? 3x plus 6 equals? You guys totally know this. If you don't talk, class is going to be terrible. Work with me here. Josh?
2 sailboat plus 1
All right.
for some sailboat living in the integers.
Yep, 2 sailboat plus 1 for some sailboat living in the integers. Okay, we know that. Alyssa, we know that what? Where do I start? What's my next part? Where do I start? We know that. I don't think you're muted anymore, but I can't hear you either. That's a little better, kind of, or not. Nope. Okay, I'm gonna let you figure out your value. That's okay. Lauren, go ahead. We know that what? 3x plus 6 equals, what do you want to do with that?
Plug in the X that we know.
Okay, so this is 3 times.
2a plus 1 plus 6.
Cool. All right, Grace, next step. We're gonna see if I can fit this whole proof on my single whiteboard here. Next step, what do you wanna do?
Turn that into 6a plus 3 plus 6.
Cool. All right. Josh, next step. What's my next step? I'm just going around in the order I see you on my screen. Josh?
6a plus 8 plus 1.
Cool. Andrew, you're gonna have to unmute yourself. Next step. What do you want to do next? Remember, we're trying to get to 2 sailboat plus 1. So what's my next step? You're unmuted, but I can't hear you either. Okay, we'll come back to you. That's fine. Grant, what do I want to do next?
Take a 2 out, and
Okay.
it'd be 2 times the quantity 3a plus 4 plus 1.
Cool. All right. And then Lauren, I'm almost done. That equals?
2 sailboat plus 1, where sailboat equals 3a plus 4 living in the integers.
Keep talking. Living in
The integers.
because.
Oh, we're using addition and multiplication.
Yep. And where does A live? Because A lives
Oh,
in
integers too.
the integers, and then we're using addition and multiplication. Okay, if this were a regular normal proof, not a biconditional proof, but a regular normal proof, you would stop at this point in time, right? You would write a therefore statement, you would be done, you would stop at this point in time. I am done with my first half, but I'm not done with the proof, so I don't put a therefore statement at this point in time. We're gonna keep going and do the reverse implication. Everybody good? All right, so let's do whiteboard number 3. All right, and so here for my reverse implication, so we're continuing the proof. Here's my reverse implication. So the book usually does it with conversely. I just mark it with a backwards arrow. You can do it either way. There's no right or wrong answer. Either one is totally okay. So we'll do a backwards arrow. And so for this one, we need to show that if 3x plus 6 is odd, then x is odd. If 3x plus 6 is odd, then x is odd. Everybody clear on what I'm trying to do? Good. Okay. Do I want to do a direct proof on this one? Where is the more complicated part of the statement that I'm trying to prove, in the hypothesis or in the conclusion? Let's do fingers 1 or 2. So more complicated part, in the hypothesis or in the conclusion? Where's my more complicated part, hypothesis or conclusion? Hypothesis 1, thank you, spectacular. When my more complicated part is in the hypothesis, what proof technique do I generally want to try? Proof by, Josh?
Contrapositive.
Yes, so instead we are going to do this part with the proof by contrapositive. Okay, so my first step is to write down the contrapositive statement. So in this case, it's if x is even, then 3x plus 6 is even. Are we good? If x is even, then 3x plus 6 is even. Everybody good? Everybody happy? Okay. All right, cool. I think we're going to do breakout rooms. This is someone that you should totally know how to do. So I am going to divide you into breakout rooms. I think that my whiteboard is going to go away at that point in time, but that's okay. And if you need to, you can just hold up your piece of paper to your computer screen and show it to somebody that way. I'm going to randomly divide you into breakout rooms. I think that means I have to stop sharing my screen. So give me just a second here. And then we're going to recreate these. Okay, so we mixed people up, I think. Yes. All right, here we go. Breakout rooms, discuss how to prove that second part. Go. Okay, you should be getting invitations to join. Okay, how's everybody doing? Still working, done, still going?
Now we're
Still
working.
going.
Okay, cool. Talk to each other, show each other what you have by holding up a picture to the screen if you need to, but do some talking. I'm gonna go join breakout room number 2.
Line 3B.
Okay, how are we doing so far? Doing
Good. I think we got it.
All right. Let's see. And I think Alyssa, oh, here she comes back. Okay, there you go. Yep, you're fine. This is why we're recording. This is not a problem. Oh, no. Oh, no. I'm ending breakout rooms. I'm sorry. I didn't mean to do that, but okay. Sorry, I inadvertently ended your breakout rooms too early. Sorry about that. My bad. Was breakout room number 1 still working, or were you close to done?
We were
Yeah,
pretty
we're-
much done.
You were pretty much done. Okay. All right. Breakout room number 2, you were pretty much done. You were close to go. All right. I think I can still share my whiteboard again. Hopefully it didn't erase. No, it did erase. Okay, so when I go into a breakout room, it erases. But here's what I did. So before I took all you guys into breakout rooms, I wrote up a proof on the whiteboard. So that'll show up in the recording. Your sailboat should be equal to 3 times something plus 3. Whatever letter you picked for X being even, your sailboat should be equal to 3 times something plus 3. All right, everybody good? Are we good? We're happy? And then you would finish with a therefore statement. So you would finish your proof with a therefore statement. I don't have my proof anymore because this is a drawback of Moodle, that it erases your whiteboard. I don't like that. But here's our therefore statement. So we would say then, therefore, X is odd if and only if 3x plus 6 is odd as desired. So this is our therefore statement at the very, very end of our proof. X is odd if and only if 3x plus 6 is odd as desired. Okay, how are you feeling about biconditional proofs? X is odd if and only if 3x plus 6 is odd as desired. How are you feeling about biconditional proofs? They're exactly the same as stuff that we've done previously. Exactly. You're just doing twice as many proofs in a particular example. Feeling good? Making sense? Okay. Do we need to do another example? I am happy to do another example if we need to, but I am also happy to let you out of class a little bit early because there is another example in my notes that you can work through, and I put you into breakout rooms already, so you've talked to each other at least once in class. If you want to see another example, I will. Normally, what I would do, so normally when I'm teaching this stuff, what I would do is 7.1 and 7.2 both in a single class period, or at least starting 7.2. But I wanted to start us slow today because I wasn't totally sure how math would go in a Zoom environment, and I wanted to give you the opportunity to play with stuff, fulfill stuff, etc. So are we good? You feeling okay with biconditional proofs? They're nothing new, really. It's just 2 pieces instead of 1 piece. Are we good? Okay, so again, couple of logistics then. I will send out a reading assignment, and I have half an hour until my next class, so I should be able to do that now. I'll send out a reading assignment that'll have your homework from chapter 7. The homework due date for chapter 7 is next Friday, April 3rd, when the test is, and then homework from 5 and 6 is due on this Friday, March 27th. Okay? Anything else? Other questions, other Zoom issues, anything else, problems you are having at this point in time? We've got 19 minutes that I don't intend to use, but now is a good time for questions. Any other questions that you're having at this point in time? Laura, or Grace, sorry, yeah.
Where is the homework found? I feel like I should know this, but
In Moodle.
got it.
So here, I can show you. Let me do a quick share screen here. I think I can get to it. So we want 224. This looks a little bit different. I can change it to your view. Hang on. Oh, my internet's being slow. Okay. Oh, reps. This is Jiffy Q. Sorry. We want your class. Okay, so here's the front page of Moodle for what you should see. Here's where I'm going to do Zoom lectures. By the way, the dates on these are wrong. These are our Zoom lectures from Monday. So I'm going to take these off of YouTube pretty soon because the dates are wrong, and because everybody was there, and because we only talked about logistics. Here's the class notes. So here's my chapter 7 notes. The first example here is the one that we just did. So X is odd if and only if 3x plus 6 is odd. So there's the first example that we did. Here's another example that I didn't run through, but you can look at it if you want to for class notes. So there's my class notes. Class resources, so here's your personal grading scheme. That's revised, that's the one that's due. And then here's the homework submissions way down at the very bottom. So here's the place where you want to submit your chapters 5 and 6 homework so you can upload a file, etc. This doesn't show me exactly what you see because I'm not a student, but that's where you can upload your homework. So that's the place where it comes in. Good? And then Grace, yep.
But where is the list of which problems we're doing?
Oh, from 5 and 6. So that'll be in the reading assignment, and I will copy it again into today's reading assignment from chapter 7.
Okay, thanks.
Cool. Let me stop sharing my screen so I can see all of you. Grant, yes.
Quick question about like the truth table for biconditional.
Yes.
Just to make sure have it right. Is it the final lines true, false, false, true?
Correct. Yep.
Okay.
True, false, false, true. Exactly. That's what your truth table for a biconditional P, if and only if Q, it's like true, false, false, true. Yes. Other questions? Anything else? Content, Moodle, course logistics, anything? Okay, this clearly was not a regular class, but was this doable? Is this workable moving forward? Are we okay with this? Mostly as okay as we can be at this point in time. All right, I'll get the recording posted on YouTube, and I'll get that up on Moodle, and then I'll get your reading assignment sent out soon. So see you guys on Friday. Play around with submitting homework on Moodle. Let me know if you have issues, and have a good couple of days. See ya.